Today we're talking about linear systems, and we've got systems of equations as well as systems of inequalities. So we're going to start with the equations. And remember that there are three methods that you can use to solve a linear system. You can solve with the graphing method, with the substitution method, or with the addition method, which is also called the elimination method. Sometimes it's also called linear combinations. We're not going to do the graphing here because I have already reviewed how to graph a line in the previous videos. So if you need to go back and look at those, you can. Just remember, I'm going to write up here at the top that when graphing, so you plot your y-intercept, you use the slope, you get the line, then you do the same thing for the other equation, but the intersection point is your answer. So it should always be, if they intersect, it's x comma y, that's your solution. If when you graph them, the lines are parallel, which will happen if they have the same slope but different y-intercepts. So same slope, different y-intercept means that there's no solution. And when your graph is of the same line, which happens same slope, same y-intercept, that's when you have infinitely many solutions. So that's a brief review of that part for you. Again, we're just not going to do actual graphing on this. I'm now going to switch over to the substitution method. So the big thing with substitution is making sure you know which variable is the best to choose to get by itself. And there'll actually be questions on your quiz that simply ask you to do that. Decide which equation and which variable. So what you're looking for, first of all, if you can, you're looking to see if you can find a variable that has a coefficient of 1 or -1. So I don't have here my coefficients -1, 2, 4, -5. I don't have any plain ones, which would be my first choice. So -1 would be my second choice. So I'm going to choose the first equation and I'm going to choose the x to get by itself when I'm doing the substitution method. So I'm going to get this x alone. So that means first I'm going to subtract 2y on both sides. That gives me -x equals -2y plus 3. And then I'm going to divide everything by -1 or change all the signs. That gives me x equals +2y minus 3. Once you have isolated your one variable, the next step is where the name of the method comes into play. We are now going to substitute this expression in place of x in my other equation. So in place of the x in the other equation, I'm going to put 2y minus 3. So notice that everything else I'm writing from that second equation is staying the same. The 4, the -5y, the -3. The only thing that's changing is I'm substituting this 2y minus 3 in place of my x. So now I just need to solve. So that means distribute and then combine like terms. So I have 3y minus 12 equals -3. Now I'm going to get y alone, so add 12 to both sides first. So plus 12 plus 12, that gives me 3y is equal to 9. And then dividing by 3, I get y equals 3. Now I'm not done. This is a system of equations. There should be something for my x and something for my y. So now I'm going to go ahead and plug this solution for y into what I got from the first step here. You can plug it into the original if you want. You just then would have to do extra work to solve, whereas here all I have to do is plug. So 2 times y is 3, so 2 times 3 is 6. 6 minus 3 is 3. So that means that x is also 3 in this case. Final step is to write that answer as an ordered pair. So 3, 3 would be my final answer. Sometimes you'll have to pay attention to the directions. Sometimes on the quiz, they might just ask you for one of the variables. So instead of typing the ordered pair, you would just type one of the coordinates. That doesn't change how you solve it. You just have to pay attention to what they're asking for specifically. All right, we're going to do the same thing now on B, substitution method. Here, when I look at the coefficients on all my variables, I don't have any ones or negative ones. So when that happens, the next thing I need to do is I need to look at the individual equations and see if I divide by the variable's coefficient, if everything would come out nicely. So in equation 1, in order to get x by itself, I would have to divide by 4. So negative 12 is evenly divisible by 4, so that works. But 6 is not. 6 divided by 4 is 3/2. So we want to avoid fractions if we can. So I definitely would not choose the x here if I can help it. So now I'm going to look at the y's. For the y's, I would have to divide by negative 12. 4 divided by negative 12 is a fraction, so is 6 divided by negative 12. So I'm going to hope that equation 2 has some better choices. So I've got 2x. If I divide 8 by 2, that comes out to 4. 10 by 2, that comes out to 5. So that's perfect. Notice that the 8 wouldn't work either. I would get fractions there. So I'm going to choose on this one the second equation, x. Now remember, it doesn't always have to be x. It can be y, whichever one's easiest. So I'm going to get this x by itself, first by subtracting the 8y on both sides. So 2x equals negative 8y plus 10. And then divide by 2 everywhere here. So I get x equals negative 4y plus 5. So that's the same as this step here. Because I began with the second equation this time, when I go to do my substitution step, I have to use the first equation because it's always the other equation. So in place of this x right here, I'm going to put in negative 4y plus 5. So 4 times negative 4y plus 5 minus 12y equals 6. Then, just like in the first one, distribute. I've got like terms to combine here. So negative 28y plus 20 equals 6. Subtract 20 on both sides. So 6 minus 20, negative 14. And then divide by the negative 28. You will have to pay attention to the directions to see whether they're going to allow you to use decimals or not. If it doesn't say anything about rounding, then you should keep fractions. My directions here don't say, so I'm going to leave this as 1/2. Now I go and I plug that y in right up here. So x equals negative 4 times 1/2 plus 5. So half of negative 4 is negative 2. Negative 2 plus 5 is 3. So that means that in this case, I'm going to get 3 1/2 as my ordered pair. All right, moving on using the addition method, which is also called the elimination method. Here, our first objective is to get opposites on one of the sets of variables so that I can get them to eliminate themselves or cancel out. So in this example, I can see that I don't have opposites already. 9 and 3 are not opposites. -3, -1 are not opposites. But I do have a coefficient of -1 here. So I could easily multiply this equation by whatever I want to make opposites in those y's. So since this equation has -3y, the opposite of -3 is +3. So if I multiply this guy by -3, and when I multiply it, it's all three terms, that would give me -9x plus 3y equals, and then I'd have -18, -3 times 6. And now look, if I copy the first equation as it was, these are opposites, -3y, +3y. So I've gotten what I needed. So now this is why this is called the addition method sometimes, because now I'm going to add them. Once you have opposites, you can add. Now when I add them, 9x plus -9x is 0, it's nothing. -3y plus 3y, also 0. 12 plus -18 is -6. Now, this is one of our special cases. It's easy to see special cases when we're using the graphing, but when we're using substitution or elimination, we don't find it as easy. What happens, and it could happen in substitution as well, is that when you're trying to do the steps, the variables all drop out and you end up with just a number statement. So in this case, when I fully simplify, my number statement is 0 equals -6. If your number statement is true, that means that it would be an infinitely many solutions type. If your number statement is false, that would be a no solution. So because this is false, 0 does not equal -6, we actually just stop the process right there and write no solution. We'll talk more about infinitely many solutions in example 3. All right, so now when I look at example 2b, I look and I don't have any coefficients of 1, and I can't multiply 6 by anything to get 7. I can multiply 5 by 2 if I want to get 10. So I multiply this equation by 2, and remember it's the whole thing. It's the whole thing, not just the y's, the whole thing. So 12x plus 10y equals 8. 7x minus 10y equals -8. So now I have opposites, so I can add them. 12x plus 7x is 19x. 10y plus -10y is 0, so those drop out. 8 plus -8, also 0. Now this, I wanted to illustrate the difference for you. This is not a no solution. Your variables did not drop out. I still need here to divide to get x alone. It just happens that 0 divided by 19 is 0. So my x coordinate is 0. To find the y coordinate, I plug it back into one of these equations, and it doesn't matter which one. I'm just going to use the top one. So when x is 0, 6 times 0 is 0. So that gives me 5/4, or 5 y equals 4. If I divide by 5, then I have y equals 4/5. Again, if it says to round, then you can feel free to use the decimal. But if it doesn't, then use the fraction. Usually on these ones, they let you use the decimal just because typing it in with a fraction is more difficult. So this would be our solution here. Now, I also want to point out, make sure you look back in the lesson, with elimination, sometimes multiplying one equation by something is not enough. Sometimes you would have to multiply both. So for instance, if the question asked how I could eliminate the x's here, I would have to multiply the top equation by 7 and the bottom equation by -6 in order to get those to cancel out. All right, so now going on to example 3. Find the value of Q so that the solution to the system is, and the way that we read this is called set notation, x comma y such that 2x minus y equals 5. This is the fancy way of writing an infinitely many solutions. So, infinitely many solutions, you start off with this x comma y, and then you write what the equation is. Notice, so if I had gotten a true statement up here, like 0 equals 0, instead of writing infinitely many solutions, we might have written x comma y such that, and then picked one of these equations. 3x minus y equals 6 is how it would look. This type of question, all it's asking you in this fancy notation is to find what value is going to make these equations multiples of each other, basically so that they're the same. Because if they have the same slope and the same y-intercept, then they're going to be the same line. So all you have to do is focus in on where your Q is. In this case, it's with my Y's. And then look at the other pieces to see what you multiplied by. So here I multiplied 2x by 6 to get 12x and 5 by 6 to get 30, which means I have to multiply this negative y by 6 in order to get what goes here. So when I multiply by 6 here, that would give me negative 6y. So negative 6y equals negative qy, which means q is 6. And that would be our solution. All right, so with the system of inequalities, we've already gone over how to graph single inequalities. When we have a system of inequalities, just like it says in the directions here, sometimes they'll say the solution is, and they'll have like a different color here, like, yellow or green or something like that. In this case, you can just kind of tell it's like the purplish overlap region. So in order to write the system of inequalities, we need to look at each line, each boundary line individually first. It doesn't matter which one you start with. So I'm going to color code them since, they're red and blue on here. I'm going to keep with red and blue. So I'm going to start with the blue line here. So I can see that it crosses the y-axis down 2. So that means that its y-intercept is negative 2. So that's my B. My slope I have to get by counting. So if I look here, I have gone up 2 units and right 2 units to get to this next exact point. So up 2, right 2, 2 over 2 is 1. So the slope of this line is 1. So you don't write 1x, you just write x. So x minus 2 is the rule for the line. Slope 1, y-intercept negative 2. Because the boundary line is dashed, that tells me that I'm going to use either a plane less than or a plane greater than. And the way I decide is based on the shading. In this case, the blue shading that goes with the blue line is above the line. So above means bigger, greater, so greater than symbol. So this would be my first inequality. Then on the red, I do the exact same thing. I look for its y-intercept, which is at 2. So that's the B in this case. Then to get to another exact point, there's an exact point right here, it looks like, and that is down to left 1. So down to left 1. Left is negative as well. So that gives me a slope of 2. So 2x is what I'm going to have there. Y-intercept positive 2. So 2x plus 2. Then it's solid, so I know I'm going to have the equals. The shading is underneath, so it's below. So I know it's a less than or equal to. The equal to part is because the line is solid. The less than is because the shading is below. Remember that with a system of equations, the answer would just be this intersection point. So I can't tell exactly where it is, but it looks like it's maybe at about -4, -6 or so. When it's inequalities, the solution is always a shaded area, the overlap in this case. So this would be the system that would match the graph that we see. Very last one is on the linear programming. So when you have a picture like this and we're looking at a feasibility region, remember that what you need to do is you need to look at the shading. So that's the overlap, which in this case is in yellow. And you need to write down what the boundary ordered pairs of that shaded region are, like basically the polygon that it makes. So I have 0, 0 here. This one is 2, 4, 6. I'm counting by twos, so 12, 14. This would be 16. So 0, 16. This one over here is 20 and 2, 4, 6 for the y coordinate. And 2, 4, 6, 8, 28. 0 would be the ordered pair that's right here. Oops, I said 0 and I wrote 30. I don't know why. 28, 0. So all you really need to do to figure out the maximum value is plug in these 4 ordered pairs and see which one gives you the biggest value for P. Now, obviously, 0, 0, that's going to give me 0. So at 0, 0, P equals 0. When I do 0, 16, that would mean I'd be plugging in 0 for x, so that'd be P equals 0 plus, and then my y is 16, so I would do 5 times 16 in my calculator, which gives me 80. So in this case, P would be 80. Now I do the same with 20, 6. X is 20, so -2 times 20 plus 5 times 6. So in this case, that would give me -40 plus 30, which is -10. So these two are eliminated so far. 80 is definitely bigger than that. And then when I try the last option, which is 28, 0, that one I know isn't going to work because it's -2 times 28 plus 0. So this is going to be a big negative. So my answer, the maximum value would be P equals 80. And that would be my final answer. And that wraps up our section.